So the journey into the vast unknown starts with a single spark, right? And for me, the spark started right in the living room with my dad, the man who introduced me to the cosmos. How did he do that? Very simple. When I was 5 years old, he stuffed me with all this. Yeah, every day there was an article about space that he will share with me, and he will tell me, Nirmell, this is your task for today. Read and then explain to me. So as I was going through his journey with him, at one point, I remember as clear as it was, as if it was yesterday. He came back home with A3 size paper with 5 important pictures in a sequence. A spark of the universe and pictures of atoms leading to spiral galaxies, and then formation of solar system and humans, animals, dinosaurs. And that one sequence taught me instantaneously, the first spark in my mind, that the universe, throughout the eons, to biology, is one huge connected story. And this wasn't just my question as a child. I believe this is the question of the entire humanity. From the past, our astronomers has been looking up, trying to figure out, are we alone in the universe? Yeah. So to get into a bit of a sense of a scale, where are we right now actually? So this is a cosmological model, basically the size of the universe. We are all in this balloon, which is expanding for the past 13.8 billion years. All right, and we are right at the front slice here. Now let's do a thought experiment. Yeah, what if this entire room was the whole observable universe? Note that I use the word observable because we have no idea how big the unobservable is. So we get into this thought process. What if this room was everything that is, right? Then what would be the size of our galaxy, our Milky Way galaxy, in this vast universe? Any idea? If you do a quick measurement, I did check the dimension of the room and all. All right. So the span of the universe here right now, I must mention the number, is about 93 billion light years across. So in this 93 billion light years across, our Milky Way galaxy could be at least 10 to 100 times smaller compared to the most finest grain of sand you can find on the floor right now. That's how small our galaxy is. Now, that's just our galaxy, and there are 2 trillion galaxies in the universe. We are one of the 2 trillion galaxies in the observable universe. And this is our Milky Way, containing about 400 billion stars and holding about 3 trillion planets. Can you imagine that? We are just in 8-planet solar system versus 1 to 3 trillion available planets in our galaxy alone. All right? And expand that to 2 trillion other galaxies. So how many types of other planets are there? We call them exoplanets or extrasolar planets. There are many types, like you can have a look here. We have the terrestrial, Neptune-like gas giant, super Earth, water worlds, hot Neptune, hot Jupiter, and even rogue planets, which doesn't actually orbit a star. Yeah. So in total, as of now, based on peer-reviewed research, astronomers have discovered up to 6,300 confirmed exoplanets in our Milky Way galaxy alone. Yeah, although we have trillions of planets, our confirmed research has given us this number as of 2026. And in that 6,300, we have about 40 to 70 Earth-like planet candidates. And when I say Earth-like planet candidates, I'm not referring to a clone of planet Earth, yeah? We have a variety of Earth. Earth like ours, up to super Earths, right? What creatures may live on those? Yeah. So back to the question, are we alone? What do you all think? Okay, good vibes there. Okay, thank you. And this is where astrobiology comes in. What is astrobiology? All right, astrobiology is the study of the origin, evolution, and distribution of life in the universe. And it's not a single subject matter. To bring astrobiology on the table, To bring astrobiology on the table, astronomy, biology, chemistry, geology, planetary science, and physics has to come together mutually, combining all these multidisciplinary fields to answer the question that we just asked a while ago. So the questions astrobiologists try to answer. These are 4 profound questions, but we start with the most important. Number 1, how did life begin on Earth? Followed by, is there life on Mars, our closest neighbor? Can icy moons have life? And are there life on exoplanets? So with these 4 questions itself, you can see the first important question was, how did life begin on Earth? So a quick one, we have no idea how life began on Earth. Yeah, we just know that Earth is 4.5 billion years old. So from 4.5 billion years old, coming to 3.8 billion years old, in the middle, in that 1 billion of awesomeness, life emerged. And where can we track? We can track up to Luca. What is Luca? Last universal common ancestor for all of us. Genetically, all our genes line back straight to Luca. So this period is where of the unknown is occurring. What happened in between? This is the question astrobiologists are struggling to answer. And the recipe of life, everybody knows that life requires water, chemicals, energy, stable environment. And what is the Goldilocks principle? Yes, we have trillions of planets in the solar system, but are all the planets suitable for habitability? Maybe not. Or maybe they are. How do we categorize that? It all starts with, are those planets located in the right orbital zone that can allow liquid water to exist? Because if liquid water can exist, we presume life can exist, because all of us cannot survive a day without water, isn't it? Okay? Life needs water. So the Goldilocks name is taken by the story here, Goldilocks, this young girl here, who goes to the tree bear house and consumes the porridge, which is not too hot, not too cold, at the right temperature. So if you place a planet at the right temperature, water may exist. And the Goldilocks, or habitable zone, is also star dependent. The smaller the star, the closer the habitable zone. The bigger the star, the further the habitable zone. So finding life in our own cosmic backyard. Now let's come back to our solar system. Before we want to try to find life on other exoplanets, why not find in our own solar system? Did the spark of life only appear on planet Earth? Or the spark was spread evenly across the solar system bodies? Think about that for a second. Yeah? If we apply the Goldilocks principle here, then Earth is right in the middle of the Goldilocks zone. But if we assume, all right, the moment it's in the Goldilocks zone, there's going to be life, then guess what? Venus and Mars are also in the zone, isn't it? Do we have life on Venus and Mars? Then the moon is also in the Goldilocks zone. Do we have life on moon? So this is where astronomers thought, maybe we have to redefine our understanding about life's habitability around star systems. What if we can go extended habitable zone? What does that mean? From the 50s to the 90s, there were a lot of space missions sent to other planetary bodies. You can see here 3 missions, which is Voyager, Galileo mission, and Cassini mission, which has visited the gas giants and the ice giants. What did they find out? Shocked the scientific world. All right? They found out that all the moons of these gas giants are actually ice-covered ocean world. If there can be water protected underneath thick ice, and the water is warm enough, it has energy, it has chemical, then why can't life possibly, with life's ingredient included, flourish in those moons? All right? Then suddenly, the spark of life expanded to a plethora of possibilities, not just on Earth, probably in all these icy moons that you are seeing right now. Okay? But how do we find life? We are here. We want to find life on Europa. I can't just take a plane to Europa tomorrow. Yes or not? We can't just send a mission to Europa. It takes years to arrive, to send back the data, right? At least 10 years to go to and fro. How do we do that? We look for biosignatures. All right, what are biosignatures? Scientific proof of past or present life. Basically, any sort of chemical proof that we can get from those planets just by measuring its light. So when you're learning astronomy, the secret is basically in the light, right? You get the light from the stars, you can break them apart, take out the rainbow, the spectrum out, and analyze what sort of chemicals could be embedded in those environments. But we don't just do that. We can't send space mission, we can't do observations all the time. We probably have proof right here on planet Earth. All right, have you heard about bacteria living in extreme environments? Yeah. In the places where normal creatures or humans can't live. These are the adventurous champions that are thriving in those environments. And they are called as extremophiles. Here I have two examples. One is the famous, all children knows this, the water bears, tardigrades, right? Can survive in space, doesn't die easily. When it dries up, curls into a ball, and it can revive itself. Right? Extremely resilient. And the other one next to it, the green color, is Conan the bacterium. Yeah, why? You can blast it with the extreme radiation in space. Even though its DNA is destroyed, it can repair its DNA and be alive like normal, like nothing happened. So why can't such creatures also evolve on other planetary bodies, especially those which are covered by ice and having ocean worlds, oceans underneath those ice? So coming back to Earth, what we do as astrobiologists, we study analog environments. So here are various analog environments that we can use to study other planetary bodies. For example, once you have analyzed all the extreme conditions here and understand what type of microbial life can thrive here, what we do, we compare with other planetary bodies. For instance, going back to the Conan the bacterium, it has enough capacity to actually probably can exist 20 meters deep under Mars. Our theory shows that it can, but is it really there? Then a mission has to go to Mars and drill, of course. But for now, the studies have shown that their existence on those worlds are highly likely. So Mars today, how does it look like? Look like a dry, dusty planet? Yes, but again, when you land the rovers, this is what you get. Like as if nothing is there, it's desolate, dry, and looks like nothing can survive there. But what if in the past Mars was actually habitable? When we study the rocks, we know that ancient Mars or Nokian Mars was actually, it had water. The water has since disappeared, vaporized into space, and most of it has gone underground. It has lost its atmosphere, planetary death, we would say. But that doesn't mean we can't go there and detect past life. This is what all the Martian rovers has been doing for the past 30 years. If you're thinking, why are they sending machines, robots, rovers there all the time, wasting time? No. It's actually digging and looking for fossilized microbial life proof. And that is astrobiology. So the frontier of astronomy, once you've sent a mission to a particular planet, what happens next? So yes, a rocket goes, delivers a mission, lands on the planet, and then what's next? Astrobiology is what's next. From Mars, we jump to Jupiter. Everybody knows Jupiter, your favorite planet, the largest planet in the solar system. But don't forget, it also has 4 of the most beautiful moons. And these are called the Galilean moons, because Galileo Galilei were the first to observe this moon orbiting around Jupiter, which changed the perception of mankind itself. By viewing this, the spark on astronomy has forever changed. We learned that Earth is orbiting around the sun and not otherwise. So here we have 4 moons. I'll just focus on one, the second one. It's called Europa. The first champion candidate in finding life in our solar system. Have we found life? No. Do we suspect? Yes, 100%. Are we going to go there anytime soon? Not humans, but now on the way. Our space telescopes are heading there, but drilling missions are probably in another 15 years, not now. Yeah. So this is Europa, a very beautiful icy moon, with proven ocean to be underneath its thick ice, right? We sometimes periodically see geysers or water vapor coming out of the surface. Why? Because it's next to the giant. The giant's gravitational pull can stretch Europa. The ice will crack, isn't it? So when the ice cracks, you have this vapor coming out. We can analyze the vapor and find for life's ingredient. From Jupiter, you jump to the next planet, Saturn. What do you have? One of the most amazing icy moons, which is called Enceladus. And why is this amazing? One of the rarest moons that is having a water fountain spraying into space for billions of years. How did a small moon like this get that much of water and then has been sharing the water out into space, like freely? Come and analyze me, you know? And NASA did just that. They sent a mission called Cassini mission that flew directly into the plumes to find out, are these water, are they containing ingredients for life? And the answer is 100% yes. And that moon has heat source, has deep ocean, well protected from radiation on the surface ice, and the spray that is coming out has proven that all the ingredients you need for life is available. So the recipe is there, right? Whatever the chef needs to do to cook up life is already there. But is life actually inside there? We can't answer, we will not answer that until it's really 100% proven, right? And within Saturn system itself, there's literally a moon that we can call like an alien moon. The rest of the moon has water like Earth, ice like Earth, and so on. But when you look at this particular yellowish moon, it's called Titan, right? Our eyes will see it cloudy, but if you look through it using infrared light, you can see through. And guess what? It is the only moon that appears like planet Earth, which means it has lakes, oceans, river, rain, thunderstorm, lightning, you name it. Exactly like Earth. But why did I call it alien? Because the liquid on those moons is not H2O. It's completely different. It's hydrocarbon. It's methane and ethane. So if you land on Titan, it's going to be like a different universe, a different dimension of Earth. Like looks like Earth, feels like Earth, but it's not Earth, yeah? So Titan is so important for astrobiology that NASA is planning for Dragonfly mission. Why? Why create a Dragonfly-like machine and, you know, make it land on Titan and fly around? For one purpose, to prove and to find habitability. Again, astrobiology is appearing as the next frontier. And those are missions that is going to be happening, but currently what is going on? These are our cosmic detectives that you should take note of. Number one is the famous rovers on Mars. The most famous is Perseverance. Right now is literally looking for microbial proof on the rocks or soils of Mars, right? The next one is JWST, which was launched 4 years ago. It is scanning exoplanets from Earth to see for signs of life in the atmosphere of exoplanets. And the third and fourth are currently ongoing. They are flying right now in space, heading to Jupiter system, one by NASA, one by ESA. ESA is European Space Agency. Why are they sending 2 missions straight to Jupiter system? Because they want to analyze Europa, Ganymede, and Callisto moon in much detail to answer this question, right? Which is itching all of us, are we alone in this universe? The next fleet of planet hunters are shown here. Immediately, that will be launched this month, end of August, is Roman telescope with a special focus to observe exoplanets directly, image it directly. The next one is also focusing on exoplanets, Plato telescope. All these are focusing on exoplanet and finding life in the universe aspect. Yeah. So, is it a must that only young students venture into astrobiology? In my case, okay, that was a completely different story. When I was young, I knew at 14 years old that I wanted to be an astrobiologist. But guess what? Malaysia didn't have that opportunity. I told myself, never mind. I will do my degree and my MBA, I will work in a different field, but I will never let go of the spark that started in me because of my dad when I was 5 years old. So I waited, believing that one day astrobiology will come to Malaysia. And during pandemic, thanks to Malaysia's first astrobiologist, Dr. Kuhan Chandru, which is in the middle, standing next to Malaysia's first astrophysicist, uh, 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 Tan Sri Mazalan Othman, right? He came, and through UKM, they opened up astrobiology field. And as a 40-year-old back then, I immediately registered and got myself into the field. It was a do or die scenario for me. I wasn't willing to let my spark die. Okay? So that spark in all of us that came when we were children, I would like to remind everybody, keep it alive, right? Never let it dim for any episode that would have occurred in your life. Yes, some people get it easy. The spark comes, you grow with it, you flow with it. But for most of us, we face a lot of roadblocks. We reach an age where we say that it's okay, maybe it's not meant for me. Well, I chose not to take it that way. I felt more fired up to bring this to the society. I said, this has pushed me even more stronger. I'm going to bring science communication, especially astronomy and astrobiology, to the public. And this was our first public talk. We have so far did 3 this year, and we are heading to the 4th in August with a special meteorite display planned. And passing the cosmic torch was my personal important mission. My father gave me the spark when I was young. And all that it took was for him to photostate some pages from magazines and give it to me. And 5 images changed my life completely. So if he could increase the spark, he could fire up the spark in me. I asked myself, when I was young, I always looked for astronomy teacher, astrobiology teacher. Where can I learn astronomy? Where can I look for information based on science? There wasn't many available in Malaysia 30 years ago, right? Then I asked myself, why am I asking this question? At 40 at that time, yeah? Why can't I be the teacher? So that question drove me to create an educational body to guide over 300 young students. There's been 4 years of weekly lessons, sharing and preparing our young minds for the next decade of new astronomy and astrobiology. So the discovery belongs to you. I want to give a small example before I end my talk. Although the machines are being built now, although the plans are being made now, the discovery is not going to be made tomorrow. It's going to be in the next decade or 2. That means we as adults sharing this to the next generation, and the future discovery will belong to you, the young ones in this room right now. And I hope you are inspired to take up this field and venture into the question that is going to bring you deep into the cosmos. Yeah? So we are on the verge of answering the oldest question in humanity history. So the instruments are being built today, but the discoveries will belong to the next generation in this very room. So never let go of your spark. So let me end the talk by just sharing what kind of latest technology we are looking at. Yeah? So here, let's move to the stars. Yeah. So trillions of galaxies, billions and billions of stars. So many exoplanets that you have seen so far. And these are the latest designs for telescopes which are coming for the next generation. It's called the Habitable World Explorer. What it can do, detect exoplanets which are possibly located in habitable zone. But most importantly, block the starlight so planets can appear and you can map it on habitable zone, zoom on the planet which possibly can have water, and then what? Analyze the light of the planet, find if there's actually water there or not, or other biosignature signals, and image the surface directly, and then presume that those planets could possibly have life or not. And by doing that, what if we can find trillions of habitable worlds? Hubble has been doing that, and continued by JWST, continued by many other space telescopes. But think about what the future holds. We are on the verge to find Earth 2.0, that will help us to answer the question, are we alone or not? Thank you very much.